This is mind-boggling. The size of container ships is measured in 20-foot equivalent units, or TEU, which quantifies how many 20-foot shipping containers they're able to carry. In the 1960s, no vessel could carry more than 1,000. But now, ultra-large container vessels have a capacity of more than 24,000. Let that sink in for a moment. That's enormous. This is Port Everglades, on Florida's eastern coast. To support future growth, a channel deepening and widening project is underway here. But how are they doing it? And crucially, how is a program of real-time monitoring ensuring it's not only safe and sustainable, but also effective? Hi, I'm Stephanie Andrews,
climate scientist,
ocean adventurer,
and system specialist at NextSense. The Port Everglades in Broward County, Florida, is going through an exciting and important transformation. Over a period of around 20 years, the US Army Corps of Engineers will be deepening the navigational channels by 6 feet and widening a portion of one of its waterways. And despite being a busy port, the sea surrounding Port Everglades is really rich in biodiversity. So to monitor and mitigate the project's impact, the Army Corps of Engineers is working alongside experts to deploy systems that will track the port's changing underwater environment before, during, and after channel expansion. To test methodologies and get an understanding of baseline environmental conditions at the port, NextSense buoys have been deployed just outside its mouth. There are 2 types of systems deployed here, and both have surface and submerged components. The larger system comprises a NextSense CB950 buoy, which, at the surface, carries an air mile weather station and a light sensor. The buoy is in acoustic communication with an extensive sensor package which sits on the seabed. This comprises an altimeter for measuring changes in the level of the seabed, a Nortec current meter, seabed scientific light sensor, and an in-situ water quality sonde. A smaller system comprises a NextSense CB75 buoy, which is connected to the seabed via a cable, which connects 2 in-situ water quality sondes, one near the surface and another near the bottom, to monitor for differences in temperature, conductivity, turbidity, and chlorophyll across varying depths. Both systems have a NextSense X3 data logger on board the buoy. From the logger, received information is transferred to the cloud, where teams can view it via WQData Live. Importantly, alerts can also be set, which trigger if a chosen parameter, such as turbidity, is close to exceeding a threshold. Once dredging begins on the project, this will enable the teams involved to monitor environmental conditions in real time and make informed decisions about the rate of dredging and how to proceed in a way that prioritizes environmental protection. Still in its test phase, it's anticipated that once dredging begins, over 15 NextSense buoys will be deployed, acting as 24/7 sentinels for the project. And extensive monitoring isn't the only way that the effect of this project on benthic organisms is being studied and ultimately mitigated. One major mitigation measure includes the transplanting of approximately 103,000 nursery-propagated corals and the relocation of existing corals away from areas that are likely to be affected. In the Port Everglades biodiverse waters, continuous monitoring before, during, and after dredging is essential in minimising environmental impacts. Data is vital to safeguarding this transition, balancing the commitment not just to development and growth, but also to the environment. Visit nextsense.com for more information. NextSense. Better data. It's never been easier.